Hi everyone. In this video, we are going to get started with the first linked list. If you have watched my last video, you must have seen with a simple error list, such as simple list as an error list, what were the major disadvantages or issues associated while performing different activities, such as adding or removing elements from the list, how it was taking a long span or amount of time for performing such operations, and how it was inefficient. So in order to remove that inefficiency, we saw how to create the linked list and how it is useful. So in this video, I'm going to show you basically through our Java programming code, that how we can create one linked list, and then how we can use it for different operations, such as adding elements or removing elements from the linked list. So we basically use the objects and references in order to create a list of items, such that an item can be efficiently inserted somewhere in the middle of the list without shifting of later elements as required for an array list. So the code currently that you are viewing here, it illustrates how such an list can be created, and a class is defined to represent each item, known as a list node. So our program code has major two classes: int node. Here we have all the useful functions which are supposed to be called here in the main function of the class custom linked list 2. So always the any node in a linked list is comprised of data to be stored in each list item, and in this case just one int or int and a reference to the next node in the list. So a special node named head is supposed to be created through our code here to represent the front of the list, and after which we can insert regular items following it. Okay, let's just review our code here. First, I'm going to take you to the main section of the program. So here, this is our class int node, and then one data val and one next node pointer. So the pointer is of the class time, again reference to the next node, and the data val is basically pointing to the data value associated with the node. Then we have a default constructor which is initializing the data val and to 0, and the next node pointer the reference type to null. So currently it does not have anything. If there is one node is to be constructed, so currently it has 0, and in the reference part it has null. That means it doesn't have any nodes following it currently. And then one parameterized constructor with adding the data value into it, and then the data val and the next node pointer through the this operator, we are assigning them to the data um, initial, and null to be assigned to the data val and next node pointer. Here it is, this parameterized constructor is to use how the data can be assigned to the data val and the next node pointer of a particular node. Then if you have two separate nodes for use of any type of functionality, such as addition, okay, so we are having the initial data and then another one node, next look. So the next look, okay, let me first tell you about this one, data init. So the first data in the integer format is supposed to be assigned to the current node, the other node to be compared to, and then next LOC, the reference or the address of the another node will be assigned to the current node which is in use, to its own reference part. How I will show you in one picture. Then this is the function for insert after. Let's say you want to insert one node LOC after a certain node. So in order to implement that, this is the section. Then to get the next node, so the location pointed by the next node, So this is the function, and it will just return the reference part of that node. And if you want to print the node data, then just printing the data value associated with that node, and the get data will return the data value without printing it. So if you, at certain point of time, if you want to know what is the data value of a node, then here is the statement for it. Now let's go to our main code. um, so here these are the variables associated. So first, head obj, so this is the initial node of our list. Then one node obj 1, node obj 2, node obj 3. So actually we have four set of nodes here. Along with head obj node, we have separate three nodes as well: node obj1, node obj2, and node obj3. And for later use, we have another temporary node called cur obj. Then head obj is supposed to be initialized using the parameterized constructor with the data value associated as -1. So what it will do, when we will execute this statement, it will come here, go to the int node and execute the part having, the part means the parameterized constructor with having only the data element value or data in it. Data in it will be assigned to the current node, that is the head obj will now be initialized with data in it, that is -1, and the node, next node pointer, the reference as null. Okay, so here this is how you are initializing the head obj. Now to insert any further nodes, you can execute in this way. So you are just initializing node obj1. So with passing the value like -1, with passing the value as 555, it will call again the parameterized constructor will, and along with it initialize the value. So now in the same way the statement will be executed, and in the same way the statement will also be executed for initializing all the three nodes. Now the main complex function, which is new to you, and it will take some time to go through it. So insert after node obj. So after head obj, we want to insert the new node that is created with 555 as the data element after our head obj. So how to do that? So to understand this insert after function, here it is. So what does it mean by this? To understand this, I'm going to take you to one activity here. Okay, so here it is. As you see, we have some segment of code here. Head obj is getting initialized, then we are creating node obj, then insert after function is called, and here the insert after function definition. This is what I'm trying to explain to you. So starting the code, first statement. So when we executed this with head obj int node -1, the single parameterized constructor will be executed, and here -1 and null will be assigned to head obj data value and the reference part, the next node pointer. Now coming on to, and here one thing, the first elements, let me take you to the last one. Let me stop it again. Yeah, there was some problem, some shaded values were there. Okay, let me explain it to you. So here the -1, the 86 reference or the address associated with the first data value of head obj will be now stored in one location 75. Now, so here is the first node creation, that is our head obj. Going on to the next statement, here node obj1 will be created with the data val 555, and as per the parameterized constructor, which is here, it will be assigned to null. Okay, so we have 555 and null in the node obj, and its initial address 84 will be stored here in the 76 location. Let's execute, and here is how the node will be created. So here is the head obj and here is your node obj. Now we are trying to insert node obj1 after this head obj to create it in the form of a linked list. So in order to do that, you have to execute the insert after function, its definition. So first this dot node pointer, that is here, this means our head obj next node pointer, that is null. Null will be assigned to temp next. So that is why null is coming to this location. Now, the node LOC, whatever it may be, the node LOC is nothing but your node obj1. Okay, if you see the code again, let me show it to you here. So here, wherever I will use the this keyword, so this keyword will represent our head obj, and the node LOC means your node obj1. So if you are calling insert after here, node LOC will directly refer to our current node to be inserted after the head obj. Okay, so the node LOC. Okay, uh, so where is that? Where am I? Okay, so here you see the node obj once 555, the reference 84 is now assigned to the next node pointer. Okay, next node pointer of head obj1 through this second statement here. Okay, so when that is overwritten here, the change will be also reflected, and the 555 from the 84 address will now move to that is move after the head obj. Okay, because here in the head obj1, the reference part 84, which is nothing but the address of the next node obj, which is supposed to be inserted after the head obj. So its address. Okay, so here is how this part of the segment of the list is keeping track of all the addresses, starting addresses of the nodes. Now when the next statement will be executed, that is temp next. So here temp next was already having null. Now as we don't have anything after the 555, the node obj1, it's supposed to have null after after its data part or in its reference part. So that is why it is supposed to be updated with null right now. So that's why, see, our head obj is now currently having the address of, that is our 84, which is nothing but the address of the data val 555 of node obj1. And as node obj is supposed to be inserted after the head obj, so the data value of node obj1, which is 84, it goes to the next node pointer or the reference part of the head obj. So here they are connected. After connection, you have to again make a change so that whatever will be the after node obj1, we are not supposed to have anything in it, so it should be null. So that thing should be updated after that. So after this, if you're going to add another one node, then this will be updated or changed with the next node's address or reference. So let's see that here. Again, we are going to execute some statements. Okay, so through the rest of the statements, as you already know, 999 and 777 to be added to our code. Through all those statements, your first node obj2 with 999 and null as the reference part or next pointer part are created. Likewise, node obj3 is created with 777 and null. Here what next statement do you have here? And see, one thing I just forgot to mention. So after having, execute it again to show you. So with all the set of rest of the statements, that is through all these statements, what we are trying here, the 999, it's supposed to be entered after the node obj1. Okay, and then our new node 777 is created. Now next node obj1 should have its next node as node obj3. So after node obj1, rather than having node obj2, it has to take in node obj3 here. So how to make that change? Okay, so first the next node pointer, this dot next node pointer means node obj1's reference part, that is 82, is supposed to be assigned to the temp next. Here it is. Then node LOC's address, which is 777's address, 80 will go to the next node pointer, that is node obj1's next node pointer. Okay, so here the starting address of 77 is supposed to be updated with the next part of node obj1. That's how they are getting connected. Now in the next statement, what we are supposed to do, whatever you have in the temp next, okay, the 82, which is the starting address of the next node obj2, that is 999, it is supposed to be linked to 777 by the third statement here. And this is how the node obj3 will be inserted in between node obj1 and node obj2. So these are all the statements which are supposed to be followed. The main logic behind this code is your this part. Uh, where is that? Insert after. Yeah, this is the part which is the most not difficult. It's a bit tricky to understand it. Okay, so this is how to enter an item, a node in between. I'm going to give you another one case. So there may be a case in contrast to the this program that you are currently viewing, that declares one reference variable for each item allocated by a new operator, right? Each time you have to use the new operator. Just think, if you have 1,000 number of nodes, what are you supposed to do there? So you need to change the code in certain way so that it will work efficiently without writing or creating so many objects for so many separate nodes. So the program commonly declares just one or few variables to manage a large number of items allocated using the new operator. How I'm going to show you that? Okay. So we don't have to change anything in the int node code. Rather, I think I have it here. Yeah, here it is. So now I'm going to close the code here. Okay. So rather than creating each time separate nodes with their data value, rather than that, you can just simply use a for loop. Okay, so that for loop, it's supposed to run for like 20 times. Okay, approximate, you can put in or add in any numbers as you want, and trying to generate random numbers each time, and using that random number you will create the current object. And then after each node, you can just call the insert after, which is this function in the int node, and you can add a single node after that. Okay, so here totally, what is the question? I just want to ask you one question. So how many number of nodes then will be created through this code here? You can say, as in here, from the for loop, that is 20 nodes can be created, because we are generating 20 times one random number and then adding 20 additions, or making 20 additions into the list. So let's see this part. So I'm going to run the code, and here see, we have the first node created the head obj, and that is assigned to last obj. So the first statement, it will call the here this single parameterized constructor, and that will create -1 the first node. And after that, each time it will generate one random number and keep on adding new node after each single node. So here is how, see, starting from here up to this part, you are having the nodes inserted. Now let's say you want to um, print the list now. So how can you print it? So just assign the beginning node, the head obj, to another one variable, that is cur obj of the int node type. So when it's not null, the cur obj, it's not null, it's supposed to print the node data. So what should it print, the data value or the reference part? It should print this dot data val. So that is how it is printing it. Okay. Now, each time you need to keep on increasing or keep on going through the list, through all the items that you have after that. So just call the get next function. Okay, the get next will just increment the array list to move through all the items by having this statement, this dot next node pointer, as each node's reference will keep the address of the next node following it. Okay, I hope I made it clear. Yeah, so this is how, rather than writing each time, creating separate nodes with the data value like this, just try to use this type of syntax instead. Okay, hope you understood the first linked list program and how to use it, and how to apply it in your codes.